When I prepared the presentation, I had a very nice introduction on the natural gas market, shift from renewable, and natural gas as an energy transitional fuel. But a lot of things have been addressed already. I don't know if it's the case to repeat on ourselves, but I'll just quickly skip through it because I think we all know what's going on now. Natural gas is taking the place of coal. So the focus of the presentation is a little bit different. Let's say it's a review of mooring system for FSRU operations. So the interest that we have on the gas side is not on fuel type or ship, but more focus on a global picture, so energy production and global usage. So the figure that I'm presenting now quickly show the shift toward renewable energy, the rise of wind and solar, and the drop in coal and oil consumption, but also show the natural gas as is selected as transition fuel, both for shipping as energy and for power generation, taking the place of coal. And this, you already presented this data in a different format, but this shows the what I call maybe the geographical imbalance between country that produces natural gas and country that consume natural gas. And the key takeaway point that I wanted to introduce is that LNG is the only feasible way to transport natural gas over long distances. Pipeline option for places from Australia to South America or to Far East is not feasible, and an introduction to the energy supply chain. Again, this has been discussed already, but so first of all, we need to understand where an FSRU enter the gas supply chain on the marine sector. This is a simple schematic that shows the three main components that compose the supply chain. We have a liquefaction facility at the port of departure, in which natural gas is transformed to a liquid state, transported in cryogenic state to LNG carriers, and then delivered to a port of arrival when a regasification facility unloaded the energy and converted it to gaseous state and sent it to the market and to the consumers. As we probably all know, FSRU entered the supply chain as port of arrival and regasification facility. LNG carriers, the berth on the side of the FSRU typically unload LNG stored in the vessel tank, and is regasified and delivered. There are several advantages to FSRUs compared to, let's say, shore-based terminal, and were already presented by the previous speaker, and they can represent a reduced upfront cost, for example, due to also by the fact the contracting strategy is quite different. FSRU tends to operate on a lease and operate base, so terminal don't own the vessel, but lease it for a fixed term of year, reducing the upfront cost. Schedule, again, for a project startup is short. We're talking about 1 year against 4 years, and the overall footprint is smaller. All the storage and regasification facilities are on board of the vessel, minimizing the amount of infrastructure needed on the shore. So FSRU can be a long-term solution for regasification, or a short-term one to cover, for example, peak in demand, or to make or to provide a solution while bigger onshore structure are built. A little bit of introduction of what an FSRU actually is based on LNG carrier design, with addition of regasification and metering module, for example. Owners love the flexibility to use an FSRU as an LNG trading carrier in between contract to make the economic of the vessel work, and using a fully seaworthy design is the best option. In certain specific cases, when the actual volume of storage required is small, the utilization of an LNG carrier design is not economically beneficial, because there is no need to use it as a trading tanker. And then we see that some FSRU in the small case are based on not self-propelled barge design. But I think these two are probably the only options. Someone can correct me if I'm wrong, but The Wilson XMAR FSRU, I think right now is laid up in Singapore waiting for a charter, and this is actually is an FSRU, probably more than FSRU, is in Bali. Majority of the vessels are seaworthy LNG carrier design. We assessed that more or less they are all similar. So what's the main difference for an FSRU project is the position where the vessel is actually located or more. In order to be economically viable, the project, the vessel needs to be as close as possible to the entry point in the gas network, or as close as possible to the end consumers. That's why we see that the majority of the FSRU are actually more on the jetty side, inside a sheltered harbor, or on sea islands near to the shore. But there are still some cases in which it's not possible to moor an FSRU in a port, for example, in developing countries, or in places in remote locations where infrastructure is not available. Therefore, need to be considered other mooring options that can basically they can lead an FSRU project to be technically viable. We see vessels more on sea islands, few meters from the shore, or few miles from the shore, and we see FSRU that are more 20 or something miles offshore, in typical what we call arch offshore environment. And what kind of mooring option are available to non-FSRU designer in order to locate an FSRU where is needed? We have said before, the majority of the vessels are jetty moor with a mooring system that is typical of the marine industry, something that you are probably more familiar to. Then we're moving more far away from the shore. We have sea islands, similar concept. Then when we move further offshore, we start seeing mooring systems that are more typical of oil and gas application. We have complex turret mooring, and we also started to see the utilization of spread mooring system. So by looking at this picture, from a mooring design point of view, I see the two ends of the spectrum. From one side, we have a very simple marine jetty side mooring, and on the other end, we have complex turret weather framing mooring system. And all of them have been applied successfully to FSRU. So the designer needs to know what are the actual options available, needs to know the limitation of each, and this is what I'm trying to do in this presentation. I'm trying to introduce the different systems in general terms, describe the main characteristic, and try to provide some advantages and disadvantages that are usually used at a concept selection phase, when it's quite important to rule out unfeasible option and include all the technical commercially available options. So starting from jetty mooring, this is probably the easiest and the most common form of mooring system. If you visit a port, we see tens, hundreds of ships moored to a quayside. The mooring system runs from the mooring winches or fairways to mooring beats and bollards and quick release hooks on the pier. And the design of a mooring system for an FSRU in terms of layout is not much different from one of any ship. Ship mooring lines are grouped with regard to the function they need to satisfy, depending if they have to resist longitudinal loads or transverse loads, depending what position of in which part of the vessel they are located. And I'm not going much into detail, but the important thing is that the analogy on a certain terms it stops here. So although the two systems look exactly the same, they can be designed. The layout can be designed with the same kind of guidance. The way the systems are designed is actually quite different. For a trading tanker visiting a port, usually mooring is seen as a temporary activity with a short duration, and the system mooring is designed on a simple quasi-static or static load balance check. For an FSRU, a jetty side mooring is seen as a long-term operation, in the same manner that is seen for an FPSO. Therefore, the type of analysis and the type of the load cases that needs to be verified is more detailed. We need to start looking into dynamic mooring analysis, combining the wave frequency and low frequency motion. And we introduce a new set of challenges that are not common in the oil and gas industry. For example, effect of shallow water on wave mechanics and complex bathymetry, ship-to-ship interaction during offloading operation, and even ship-to-shore interaction in some cases is considered, or loads from passing vessel. And all these designs need to satisfy a specific set of class rules that is quite inspired by the offshore oil and gas industry. So it's a quite severe set of rules. And so the takeaway point is, yes, they are indeed something that we are familiar with, but the type of specification, the type of capacity of the system, and the type of the design life as well. So fatigue, for example, is play a role as well, is quite different from what we are commonly used to. Just to give then a little bit of idea on advantages and other disadvantages on jetty side mooring. Jetty side is an established and well-known technology, and there is a long list of contractors that can actually provide the work. And more importantly, there is a big pool of local contractors as well. So in some countries, when there is a need for local content requirement, a structure of this type is usually a good thing. They provide easy access to the vessel, and the marine facilities are less exposed to the environment, providing benefit for maintenance and operation and wear. The main advantages and disadvantages are that building a jetty, if it's not available, is a substantial work that can take years. If the vessel is very close to the shore, it's possible that there is need for a dredging activity for either the startup or also maintenance dredging during operation. And these, for example, we have seen in some cases where dredging was a stop for the project, for selection of specific location, then create a shipping hazard because they can obstruct the traffic routes. And they are also close to local shore community, and they can provide an issue for the approval process of the project. And in some countries there is also a security risk, a security concern, with all the structure be accessible from the shore. So moving one step further offshore, we have another type of system we call sea islands. The concept of mooring is exactly the same. The vessel is more on the side of the pier, but in this case there is no physical connection to the shore anymore. It's a quite broad definition because it includes systems that are few meters from land, the system that can be actually a few miles offshore in the middle of bays. But the way we decided to split between jetty connected to shore and not connected to shore is for this type of project there is the need to lay a pipeline on the seabed generally and change the contracting strategy and also change sometimes the balance on overall cost for the project. Technical consideration of the design of this system are quite similar to previously seen shore-connected jetty mooring, but now the vessel is more exposed to the open of the environment. There is probably the need to plan for disconnection or a procedure for emergency disconnection. And the terminal availability is also reduced, especially for offloading operation. This still tends to occur side by side. But in some cases, when, for example, there is more, we are talking about what we call a cross-jetty layout, when the LNG carrier is actually more on the other side of the jetty, LNG transfer through the sea island. And they can be used to enhance, for example, availability. What are advantages and disadvantages compared to the previous described mooring system? By moving the terminal further away from the shore, we can access deeper water, removing the requirement for dredging. Again, it's established with no technology. It's the same it's the same type of structure as a shore-connected jetty. They provide additional safety and security, since the pipe is not access to the pipe and is not feasible. and the structure is not accessible from the shore. Moving away produces less visual impact compared to a shore-connected jetty, and moving aside from port, we have a lesser impact on marine traffic. The main disadvantages are the one that we basically discussed a few minutes ago. The exposure to the environment does not produce the same amount of availability and reduce the number of locations in which this system can be used. And in some cases, the cost of laying a pipeline is a big part on the overall cost of the project. So moving further out, we enter in the domain of oil and gas mooring solution. So if we need to locate our FSRU in more exposed to the open, we need to design our mooring system in the same manner that is designed for an FPSO unit. The system of choice for FSRU are typically weather-bending mooring system. For who is not familiar with it, weather-bending mooring system, the vessel is allowed to rotate around a single point that is called the turret, which is, for example, this structure here, in which all the mooring lines and mooring riser terminates. By doing so, the vessel aligns itself with the prevailing environment, reducing environmental loads and reducing vessel motions, and permits to units to be more in harsh environment. So, for example, in the North Sea, which of course is not the case, but this is the case, but as an example. For an FSRU project, we have seen three types of mooring system, of turret mooring system, or sorry, weather-bending mooring system apply. We have permanent turret system, disconnectable turret system, and yoke system. I'll try to go quickly through all of them, describing a little bit the main characteristic and pro and cons. We start with a permanent turret. So in a permanent turret, the vessel, I'll say the wall is permanently moored, so there is no disconnection capability. And permanent turret can be defined with respect to the location where the turret is along the vessel. The most common type is external cantilever, where the turret is located at the bow of the vessel, above the free surface. Other type of turret can be column turret, where the turret is at the keel level, always at the bow, outside the hull, or internal turret, where the turret is, in this case, in a landing pool inside a vessel hold. Regardless of the type of turret, they all share the same components. So starting from the bottom of this is to introduce this picture. This is a snapshot of a 3D model of the turret for the Toscana FSRU that is permanently moored offshore Livorno in I think 120 meter water circa. So you can see from let's start from the bottom. We have what we call the chain table, where mooring line terminates and riser enter the hull through bend stiffener. Then going all the way up, we reach the main deck height of the vessel, where we have a platform that we call the turret head. And the turret head, usually we have the bearing, the slewing bearing. This is the mechanical piece of equipment that allows the structure of the turret to remain stationary while the vessel rotates around it. There are different configurations of bearing. They can be all located on the main deck. Some of them, in some turret, like this one, for example, there is also a smaller sliding bearing at the keel level. Some of them are boogie wheels, so there is there are a lot of options. Above the turret head, we have all the geostationary pipework, so all the pipework is connected to the chain table that terminates into a swivel. The swivel is a mechanical equipment that allows fluid transfer between a fixed pipe and a rotating one. So while the bearing provides a mechanical coupling, the swivel provides the fluid coupling between the vessel and the seabed. So in this case on FSRU, now gas is pumped through the swivel, reaches inside the piping of the turret, then enter the column, and then is sent out with the flexible risers. What are the design considerations for turret mooring for FSRUs? We have seen in the previous slide different types of turret, but what we can say that column turret are the best suited to be utilized in an FSRU project. And this is due to the shape of the FSRU. The FSRU are indeed LNG carrier design, and there is not much steel at the main deck level to allow for load transfer. Therefore, a structure like a column turret that integrates both a main deck at keel level allows for an easy integration with small modification work on the vessel compared to other systems. But although I say that it requires less modification work, there is always the thing that installing a turret on a vessel is a major modification that in some cases does not allow the vessel to use an LNG carrier anymore, because once the vessel is permanently moored, it's classed as an offshore installation, and mooring system is So if you want to quickly go through the advantages, it's a well-known technology and allow FSRU to be more in the open, in harsher environment. In case the vessel is equipped with thruster, they also allow for weather vaning to ease offloading operation by sheltering the incoming LNG tanker. The main disadvantages are cost-related. Turrets require quite elevated capex for some mechanical infrastructure. You require daydock for installation, and something that we didn't discuss for time, there is also a lower bound application limit due to the clearance between the riser and the vessel keel when the ship weather vane on top of the riser. Another type of turret are a disconnectable turret buoy, like the one that the previous presenter discussed. In this case, mooring line and riser terminates into a mooring buoy that is pulled into a moon pool inside the FSRU hull. This type on the left, there are different types of mooring buoys, but the type on the left is the only one utilized in FSRUs. The main advantages are that in this case, it's possible to moor the vessel in quite harsh environment with small infrastructure, because in case of storm, the vessel can disconnect and sail away. It can be applied to shallow water depth because the weather requirements are smaller, and one vessel can connect to several buoys, simplifying the switching from one project to the other. Disadvantages: there are only a limited number of suppliers that can provide the system, and there are a limited number of FSRU that can actually receive it. The last type of weather vane mooring system is a yoke. There are currently 2 FSRU mooring using a yoke. In the case of a yoke, the turret is connected to the seabed either via turret or a seabed template, and the vessel is connected to the turret using a counterweight structure called the yoke. The fact that the restoring force is provided by a well-defined component allows the system to be installed in shallow water depth, something 20 meters. It is not available on common moored vessel, and it can be utilized in quite benign environment. I think the limit is around 5.5–6 meters HS. There are different systems depending if the turret is above the seabed or above the free surface or on the seabed. In the case we have turret yoke or we have submerged yoke. Main advantages, as I said before, you can access to shallower water, reduce pipeline lengths. Modification of the vessel are reduced to the main deck level. Main disadvantages: yoke is an expensive piece of equipment, only a limited number of suppliers can provide it, and a submerged swivel for submerged yoke is a type of equipment that is not accepted by all let's say, operator. The last type of system that I'm going to discuss is something that has not been seen today, right now, in the FSRU industry, but it starts to take in its place, and we are talking about spread mooring system. Spread mooring system is the simple means of mooring for an offshore vessel. The vessel is fixed headed. It can be used when the environment has a prevalent direction. Vessel is headed toward the prevalent environmental direction, and moored to the seabed using a mooring chain connected to the deck or the side or the keel of the vessel. There is no application for FSRU because they always have been concerned or interference between mooring lines and approaching LNG carrier for offloading. But we have seen now that for the El Salvador FSRU, a particular type of spread buoy system has been considered. We already discussed advantages. It's quite an expensive solution. There is no need of complex mechanical equipment. Main disadvantages, there are stops of Faris utilization or interference with the floating operation. There are other set of technology that we are not going to discuss because they are not properly defined and enter into the either category of SRU or the category of mooring, but there are other options available, such as gravity-based structure, jetty-less transfer solution, in which the liquefaction is still on shore base, but the transfer occurs without the need for a jetty, or there are solutions that try to introduce a floating dock with regasification facility for the berthing of an incoming LNG carrier. All the discussion that I try to quickly rush through this afternoon are summarized in the paper in a sort of flowchart map, in which we try to identify the possible solution, even different the specific project constraint. And just to conclude, I mean, the majority of FSRU are indeed quayside moored vessel in nice harbor, but a knowledge of all options available allows projects that otherwise are considered unfeasible, both technically or economically, to be actually viable and to go ahead. Thank you.